Good day and welcome to Big Bad Tech. I'm your instructor Jim Pytel, and today we'll identify and configure basic circuit protection mechanisms on the Omron 3G3JX-AE004 motor drive. Given the range of customizable features available on this drive, this could be a rather lengthy discussion, but to keep this manageable, we'll limit our discussion to errors, overloads, warnings, and active overload limitation mechanisms employed by the Omron 3G3JX-AE004 motor drive. This lecture is predicated on the assumption that viewers watch the Configuring Multifunction Outputs on the Omron 3G3JX-AE004 motor drive lecture available at the Big Bad Tech channel, since we'll be configuring the multifunction digital output P1 and multifunction electromechanical relay output to execute different functions during this application exercise. If you haven't watched this lecture yet or only dimly recall its contents, please take the time to do so now. Additionally, since we'll be dealing with this particular manufacturer's parameter programming process and navigation within it, it may be helpful to download the associated datasheet and/or user manual. Before making use of the Omron 3G3JX-AE004 motor drive, we'll initialize the drive to a default state and clear any errors using the initialization and protection parameter B084. Then we'll program it to recognize a 200-watt motor with a nominal rotational speed of 1800 RPM using the motor settings parameters H003 and H004. Finally, we'll program the drive to recognize an external speed potentiometer input using extended function parameter A001. This start state establishes a 60 Hz base frequency, a 60 Hz maximum frequency, forward default rotation, a linear volts per Hertz ratio, a 10-second linear acceleration time, and a 10-second linear deceleration time, among other properties. This motor drive is now ready for today's activities. First and foremost, this drive includes important basic safety protection mechanisms that recognize and respond to basic fault conditions, including overcurrent events, overloads, over and under voltage events, memory, communication, and processor errors, and thermal errors, to name just a few. A full list of their associated error codes appear in the user's manual. For example, error code E01 indicates an overcurrent trip while in constant speed mode. The user's manual further specifies that an overcurrent trip while in constant speed mode will depower the output. The default response for most of these important fault conditions is to depower the output and signal an alarm with the appropriate error code. However, the Omron 3G3JX-AE004 motor drive also allows the user to customize this response depending upon the needs of the system. Alternate responses to a fault condition include an immediate restart or a restart after a user customizable wait time. Additionally, the restart experience can be customized to initiate the restart with an acceleration period, match frequency, or match frequency, then decelerate. Beyond this customized restart ability, the Omron 3G3JX-AE004 motor drive also includes the ability to ride out momentary loss of supply voltage for a brief time, potentially freeing an ongoing process from interruption. This level of customization is definitely treading beyond the territory of what you need to know and well inside the nice to know land, so we'll just leave it at that for now. For our purposes, we'll assume the drive's response to any of these fault conditions is to signal an alarm and output the appropriate error code. Should a fault occur, the drive will log the time and value at the time of occurrence and execute the pre-programmed response. Beyond the passive recognition of a fault, the Omron 3G3JX-AE004 motor drive can be configured to actively respond to an error using the multifunction digital output P1 or the multifunction electromechanical relay output executing the 05 alarm output function. As one such application, consider a drive that ordinarily accelerates and decelerates a motor and applied load during regular operation without the needs of a friction brake. However, in the case of an emergency, needs to engage a friction brake. In this application, the solenoid of a spring-operated, electrically released friction brake is continually energized via the normally closed side of the multifunction electromechanical relay output, executing the alarm function, thus keeping the friction brake continually disengaged during normal operation. If, however, the drive experiences an error, be it an overcurrent, a loss of supply voltage, or some externally triggered emergency event, an alarm is triggered and the multifunction electromechanical relay output executing the alarm function changes state and opens, thus de-energizing the brake solenoid. The spring-applied electrically released friction brake would engage and lock the rotor in place without a deceleration period whenever the drive experiences an error, even if the error depowers the drive's output. One of the more important alarm events is E05, an overload trip. If you recall, an overload event is a high current draw that, while temporarily permissible, may be damaging if it is sustained for any length of time. An example of an overload condition might be when a motor experiences unusually high torque or the rotor locks up. These periods of sustained high current draw might damage a motor's insulation and windings over time due to high heat. An overload is therefore functions of two quantities: current magnitude and time. If you recall from the overload relays lecture, available at the Big Bad Tech channel, a Class 10 electromechanical overload relay will trip in 10 seconds if current is 6 times the rated value, with a curve describing the behavior of the overload at different current magnitudes. A motor drive can mimic the behavior of an electromechanical overload relay by continually monitoring both current magnitude and time. If a period of sustained high current draw is detected, an overload trip can be signaled. The Omron 3G3JX-AE004 motor drive coordinates overload response using protection parameter B012, electronic thermal level. The default level is the rated current of this drive, in this case 2.6 amps, as indicated by the nameplate affixed to the side of the drive. A graph of trip time as a function of current might look something like this. Given a current draw of 2 times the rated current, it would experience an overload trip in a relatively quick 4 seconds. Whereas if the drive was experiencing a smaller current draw of 1.5 times the rated current, it would experience an overload trip in a relatively longer 60 seconds. The point being that a drive can overload the motor as long as it is brief and controlled. Overloads only become an issue if they're sustained. Let's examine the overload behavior of the Omron 3G3JX-AE004 motor drive. First, we need to establish some baseline current data. With parameter D002, output current monitor, being displayed, when an operator presses run, during acceleration, current kind of peaks out around 1.7-ish amps. While in constant speed mode, motor drive appears to be drawing 1.2 to 1.1-ish amps. When an operator presses stop, during deceleration, current kind of peaks out at maybe 1.3-ish amps. Note at no time did the drive fault out due to an overload event, given the motor is properly sized and completely unloaded. Let's trick this drive into thinking the motor is overloaded. Navigate to protection parameter B012, electronic thermal level. As anticipated, the default value is the rated current of 2.6 amps. Let's decrement this value to, let's say, 1.09 amps. This value is just below the steady state run value of 1.1 to 1.2-ish amps. Given this relationship, the drive should run, however, it will eventually overload. Let's see if this is the case. As expected, when an operator presses run, the motor drive linearly increases applied voltage and excitation frequency over the acceleration period. Note the bottom pilot light is low side switched by multifunction digital output P1 executing the run function. The motor accelerates and speed stabilizes. Note the top pilot light is high side switched by the multifunction electromechanical relay output executing the constant speed arrival function. While we sit around and wait for this motor to overload, does anybody know any good jokes? I do. What do you get if you cross an elephant and a rhino? Elephino. That was pretty lame, huh? Speaking of lame, one of my students asked me the other day, in all seriousness, who is Flava Flav? And I'm like, who is Flava Flav? Who are you? Get out of my sight. Don't even come back till you get yourself some culture. Aha! Maybe a minute or so into the experiment, the drive powers off the output and faults out. The data display says E05, corresponding to an overload trip as we anticipated. Note the alarm LED on the drive is illuminated. Like I mentioned earlier, rather than switching some dumb pilot light using the constant speed arrival function, the multifunction electromechanical relay output could be put to better use switching a brake solenoid using the alarm output function to lock the de-energized motor in place for emergency purposes if the application warranted this level of protection. A technician experiencing an overload trip must wait 10 seconds and then reset the drive to resume operation. Let's return protection parameter B012 electronic thermal level back to the default state of 2.6 amps. That way we're not continually faulting out due to an early overload. By the way, the origin of frequent unwarranted overloads may simply be the fact that this drive's overload limit is set too low. Never assume for a moment someone isn't diddling with the equipment in your absence. Trust no one, least of all your lazy lab partner.